one. I used to make it like, instead of 2, it was 6 slides per page, and it was just so tiny. So I'm like, oh, what the heck. And some semesters I have students buy these in the bookstore, but I want to have the flexibility to kind of change it up. So, oh, thanks for going to go ahead and your assignment, I'll pick up your assignments. Yay. I don't like writing things, but yay! Any questions about Canvas? Are you finding your way around okay? Okay, yep.
It's coming. It's in the mail. Yeah.
Okay.
I don't saw the teacher, but that's why I think the teacher today we get it to you.
Well, you awesome. Ultimately, is I can just if you get email, I won't be at my desk until like 1 o'clock, but I can send you a copy of the questions. It's okay. Email, and then you can just get your notes.
Okay.
So you don't. Does that sound okay?
Okay. Because I'll have a class too.
Do you have a mic? Just gonna say, I'll email it to you, and all things considered, if you even just want to respond. And do that. Yeah, the whole book thing at the beginning of the semester. So. Okay. All right. So, yeah. So you might, I think this is interesting, if you think about it, you know, we are modern people, but folks before us may have looked at an object, and the object's here, okay, they go away, say they're cavemen, okay, they go away, they come back later, and the object's there. Like, wow, you know, that's amazing. It's just a miracle. I believe in miracles. I think I might have mentioned that the other day, but that's not a miracle. Okay? In order for something to get from position A to position B, somehow some sort of force, if it's a push force, okay, it could be a lift, move over force, okay, but there has to be some force involved. Okay, it's not magic, people, okay? So, we're going to talk about those forces. Some force needs to be applied to get an object from position A to position B. Although, wouldn't it be fun before the days of science and you're just like, you're just going to make stuff up, you know? But that's how science starts. And then, of course, we apply the scientific method and we see if it really is the real deal. So, forces can be pushes or pulls. Forces are all around us, all sorts of different forces. The force of friction, okay? One of the things is that if I take this, and this is where I move this table out here. If I do this, oops, stop there. Well, it's not works too. If I do this, okay, it stopped actually because of the force of friction and in conjunction with the force of gravity. That thing's being pulled towards the center of the earth, just like we all are. So friction and gravity made that stop. What if I try to do this? Why doesn't that go with the same force? What's wrong with that? The friction, yeah, that was. So we have force of friction, force of gravity, push force, a pull force. Okay. Sometimes you see the forces, sometimes you don't see the forces. There are forces like the force of gravity. Goodness, what a force of gravity. Okay, otherwise we would be leaving this planet, quite frankly. Okay, sometimes you see them, or sometimes you don't see them. Sometimes they don't actually make something move. Just because something's not moving doesn't mean a force isn't acting upon it. So in science, we have to talk about units that are used across the world. International units. And the international unit of a force is a Newton. Now, a Newton, the force, like this could be 1 Newton, this could be 2 Newtons, this could be 3 Newtons, okay? A force applied. It's units of Newtons. that unit of a Newton can be broken down further into kilograms, meters per second squared. Now, anytime you see this little slash right here, okay, anytime you see that little slash right there, I want you to think of the word per, P-E-R. My little thing's not wanting to, per. That's P-E-R there. Cool thing about things that are pers is we could kind of, I call it unpack it. We could take the kilogram, meters, slash second squared, we can unpack it. What that really means is kilogram, meters, that means times, right, over second squared. So anything that follows the per is what we call the denominator. Kilogram, meters per second squared. It's a newton. It's a force. That could be helpful later. So examples of forces are pushing, pulling, force of gravity, force of friction. The wind is a force. The wind is an amazing thing. All the wind is doing is going, have you heard, because we're going to talk about weather patterns. We're going to talk about meteorology a little bit. You've probably heard of sometimes there's a high pressure or sometimes there's a low pressure. What that literally means is the high pressure means, oh, these are my gas particles. That's my high pressure. And my low pressure is this. There's not as many gas particles. So all wind is if you have these two options, guess what? Where the gas particles are squished together, they're going to move to where it's a low pressure. So high to low, that's all wind is. That's it. Okay, but anyway, what else we got? So in, so speaking at the kind of the small level, well, kind of the small level, we can look at all the forces that are in the universe, not just on our planet and our solar system, but in the universe. We can kind of break them down into actually 4 things. Okay, the first 2 are kind of, well, they seem kind of strong. The strong force has to do with, if you were to look at an atom, we're going to be talking more about atoms, but a strong force is keeping that atom together. We just take atoms for granted, but they're very important. Electromagnetic force is where you have like a plus and a minus. Do a plus and a minus if something's positively charged and negatively charged. Your choices are they going to attract or repulse? How many people think they're going to attract? A plus and a minus. They are going to attract. Unlike attracts unlike. If you have a plus and a plus, they would repulse. Okay, so attractive forces between opposite charged. This one also has to do with the atom. Okay, weak force. And actually, I believe it's the weak force when we do some sort of nuclear reaction that actually is involved when mass is converted to energy. And of course, the force of gravity. So those are 4 things that are kind of what we call the fundamental forces that work in our universe. Go to a different universe, maybe a different set of fundamental forces. There is that thing out there, multi-universe theory. I'm not so sure. It might be sort of the right deal. So just up here just a minute ago, we kind of talked about multiple forces. So I can have a force with my finger, and I can apply a force, but actually I'm going to have to keep applying it here because I have friction, okay? So I have my net forces, and we're not going to do a whole lot with this, but my net forces would be this, and friction's going like this, and gravity's going like this, okay? So in physics, a lot of times what we do is kind of draw these little arrows representing this, this, and this, okay? And then just like you have a net worth, like your worth has what your car is, maybe what your kids are, so can't put a price tag on your kids, like what your clothes are, that's your net worth, what's in your bank account. So when we talk about net forces, we're talking about all the forces on an object. So I mentioned arrows. So I have 3 arrows up here. I'm I'm going to call them from left to right. Arrow A, these are all forces, representing forces, B and C. Which of these, A, B, or C, looks like the wimpiest force? B. Why did you say B? Because it's shorter, exactly. And these are what we call vectors, V-E-C-T-O-R-S, vectors. That's up there. So a cool thing is actually you can spatially add these together. I could connect these three at the little beginning of the arrows, and I could come up with a net result. But okay, which one is heading due west? C. That's what it looks like to me. Yep. So forces have what we call magnitude. You can, like, the longer it is, represented with a vector, the stronger the force. And then they also have direction. Forces have both magnitude and direction. Okay, tug of war. All right, so we have, oh my goodness. Yep, we just have 2 people over here, 3 people over here. Now, right here, can you see this F1 and F2? What does it look like to you? Is that, with the tug of war, is it moving either way? Why not? I agree. Because they're equal. Yep. Well, there's no vat of mud there, but if there was a vat of mud, who should worry? The left or the right? The people over here on the left, yeah. So finally, you can actually kind of see this arrow's longer. Yeah, they're not equal. F2 is stronger. Well, yeah, because they got 3 people. F2 is stronger. And then this is the net force is not 0. The net force actually is in that direction with that magnitude. So, net forces. Cool. So in the lab on, you guys' lab is on Thursday. Yes. The lab on Thursday, and hopefully Wednesday I'll get you the handout. But the lab on Thursday, we're going to be talking about speed. Okay, driving down the road today, we were kind of all driving, hopefully pretty conservative on our speed. Have you guys seen that? I saw it on YouTube, a little YouTube video about, caption was, "This is why we don't drive fast in bad weather." And so they had some idiot, there's always one driving too fast, and they showed him, spinning out. I think hopefully nobody is really hurt. So speed, how fast you're going. So in order to get speed, what we would do is, if I wanted to know the speed of this object, I would need to know the distance it went from A to B. What else would I need to know? The time, exactly. So you guys know. And is it time divided by distance or distance divided by time? Miles per hour. Yeah, I always have to think of something. Miles per hour. It is distance divided by time. Exactly. Speed. Yep. So speed is total distance divided by total time. And you're going to have some problems that are due on, on Wednesday. Some speed problems. What does it mean by average speed? What I'll kind of answer that my own question, or my own way. So if this is the distance, this is A to B, okay? This thing could be going fast and then slow, and then fast and then slow, fast and slow. Its speed is definitely not constant. But if you just looked at the overall distance and the overall time, that would be the average. So that's kind of what that means. And that's usually the way we do problems. The opposite of average would be instantaneous. And instantaneous is kind of a, if this guy's going fast, slow, fast, slow, fast, slow, we'd have to kind of break up the segment, wouldn't we? There's ways to do that. But. All right, red car. So I'm going to go ahead and write So speed is equal to distance divided by time. So what's the speed here? What do you think? Distance, I got 20 meters. And one of the things, I know it's a small thing, but if you haven't done much like science problems, you really should keep the units with the numbers. So we have 20 meters and it helps the whole problem. And what's the time? 1 second. And I'll even go like 1.0 second, S for second. So, oops, sorry, 20 meters per second. Does that seem right? Sorry, kind of have to be careful with that. Well, the car continues. And notice to go 1 more second, or it went 1 more second, and it went 20 more miles. Is the speed increasing, decreasing, or staying the same? Seems like it's staying the same to me. We could isolate this right here. And we could say speed for that second segment, it still went 20 meters. And the time was, let's see, it's always final ones. It went from the final time was 2.0 seconds. The initial time was 1.0 seconds for that interval. And that's equal to 1.0 seconds. So I'm back to 20 meters per second. Does that make sense? Well, you can't see it, but I'll go ahead and erase this. So we basically checked how far it went, how much time, how far it went, how much time, okay, for 1, 2, 3, 4, 5 segments. Let me go ahead and erase this. All right. Now, one thing about it is we could come up with remember a minute ago I said you can kind of capture kind of the instantaneous thing, or you can just go from here to there. Voila. Let's do that last one. How far did it go over all those segments? How many people think 20 meters? 40, 60, 80. Yep. 80 meters in how much time? Yep. 4.0 seconds. So, I need to get my calculator out for this, but, you know, that we come to the same thing. We'll be talking more about this on Wednesday, but starts with letter A. What do we call it when something changes in speed? Acceleration. Yep, exactly. You got it. So how fast is this car moving? I think maybe if you jotted this down, that would be great. What is its average speed? Any questions about that? Not just this problem, but I'm a firm believer in science problems in general, drawing little sketches when they're appropriate, pictures. Some of you guys are great drawers. So, take your time. All right, so speed. What's kind of like speed but starts with letter V? Velocity. Very good. They are not the same. They are related, but they're not the same. Okay. I'm going to come back to this. So, all right. So just in general, working science problems, I mentioned draw pictures, doodle. When in doubt, I call it stalling sometimes. I teach chemistry, and sometimes I just doodle till the answer comes to me. Another thing is oftentimes to kind of pull numbers out of the paragraph. It's funny because I can remember grade school, even story problems. People hated story problems. Well, sometimes you can kind of pull the numbers out and make it seem more doable. I mentioned always use the units. So here it was important that I just didn't put 20 over 1. I put 20 meters over 1 second. And it really helps a lot. And then notice I had a couple things that are not optional for this class anyway. So always use units, you have to do that, it's not optional. And the other thing is always show all of your work, okay? So sometimes people come into classes like this and they're like, oh, I can just look at it and know the answer, and I bet you can. Well, if that's the case, then kind of reverse engineer it. If you just automatically know the answer, write the answer down and kind of write what you did to get there. Okay, so this will be due. I know I'm gonna, actually, anybody else want me to send you a copy for now? Are you still trying to get the book? And I can send you a copy of the homework for now. One of the things with my PowerPoint slides, I wished I would have, like, on the slides, had this on there, but I'm not that with it yet. Maybe I will get with it. Maybe I won't. Okay. This is actually the first of 2 sets that are going to be due on Wednesday. That's fine. Any questions? I'm excited that you can actually see the answers out in Canvas. Let me know if you can't find them, okay? So, it makes my life easier. Okay. So, this is the same problem we worked just a minute ago. We came up with whether it's an instantaneous speed, like interval by interval, or whether you go the whole 4 seconds worth, we came up with 20 meters per second. Oh yeah, now I remember. It's like, what am I doing? So, aside from what this question is, what if you were going 60 miles per hour and you had to go 30 miles? How long would it take? Half an hour, exactly. Let's think that out. So, this whiteboard just seems like it's a little better on this side. What I just said is you're driving 60 miles per hour. Question, what did I say? How long will it take to get 30 miles down the road? And the answer was 30 minutes, half hour, right? So the way you work this, 30 miles, 60 miles per hour, this MPH, are we good with this? What that really means is 60 miles per 1 hour. Are we good with that? I think that would really help if we're all on the same page with that. So then to work this, what I would do, and it's called and your textbook talks about this, it's called using, letting the units cancel. I'm going to set up a term. Actually, if I make my first term 30 miles, I'm going to put that over 1. Now, I'm going to put a blank here. Do you see, see, I'm getting ahead of myself. Trapped. I wish I had done this before. So here's one. So I'm going to come back to that. What if you have fractions? 2/3 times 5/2 times 3/5. Does anybody remember how you can simplify this? The common denominator, exactly. Let things cancel out. So I'm going to let my 3 cancel out. Anything else I can cancel out? My 2s. Goodness. What else? 5s. This wasn't a very good example. I'm actually going to get 1 here. Okay, the answer is 1 here. Just like this, instead of numbers, I want us to switch to units. Do you see where I can take the 60 miles per hour and I can flip it and I can put 60 miles, and the reason I'm doing that is because I want those miles to cancel in 1 hour. So what do we get there? We get 1/2. Oh, sorry. I do that, my units cancel out. The numbers wise, I have the number 30 divided by 60, which is 1/2, and the units I have left are hours. That's it. It's just kind of a way, nice way to work problems. Now, in this class, I'm not going to hold you to this method. You're going to see this is how I work problems. But it's really helpful. Okay, so with that in mind, let's work this problem. So how would I write 20 meters per second? 20 meters over 1 second. Yep. So just kind of like I did a minute ago, I'm gonna reserve this as actually my second thing I'm gonna put work in my problem. The first thing I'm gonna put is this 2.5 seconds. I'm going to go ahead and put it over 1 because I'm going to use this technique of letting things cancel. So what do you think? Am I going to just insert this here, or I'm going to flip it like I did last time? Just insert it. 20 meters in 1 second. Cool. Let's see, 2 times 20 is 40, and then a half is 50. So 50, what would the units be? Meters. Yep. Sit. I'm not going to have, so this is actually the answer to this. So hopefully you got it in the little box. I have a follow-up question. How long will it take in seconds to travel 136 meters at this speed? So to work the second problem, what will my first number be? 136 meters. I'm going to go ahead and put it over 1. Now, how can I use my 20 meters per second to my advantage to have meters cancel? Yep, flip it. Very good. I'll put 20 meters in the bottom, 1 second in the top. Let's see. 2, 23, 2. Oh gosh. Okay. I got 6. What would the units be? Yay. Any questions about that? Oh, we got a few more. All right. So we got a figure. We could have drawn this figure if we had to, but it says using this figure, what is the speed of light as it travels from the sun to the earth in kilometers per second? Oh, well, this doesn't look too bad. So my target is kilometers per second, and I see kilometers here. I see seconds down here. Now, so yeah, we did talk about scientific notation, didn't we? So don't make it harder than it is. I think I'll try working this on the slide and see if my stylus works. So all I'm going to do is take this number and divide it by this number. 1 point, and this will give us some more. I brought my calculators if anybody wants to borrow one again. Remember to keep our units, bring our units along. By the way, how fast light travels is actually a constant in a vacuum. So it's pretty much a vacuum between the Earth and the Sun. Anybody want a bar calculator? I thought I had it. Oh, see, I had them out. What's that?
I'm good.
You're good? Okay. Oh, okay. So I got 3 with 5 zeros. That seem right? How many people got 5 zeros? How many people got 6 zeros? Well, let's see if I can. I don't think I can do this. I have a calculator here. There's an app for that. I think it's a is this scientific calculator? Yeah, and this one it's EXP. So to put in the first number, I'm going to go 1.5. So 1, not, yeah, that's the coefficient part. And on this one, I'm going to hit the EXP key. And then I'm going to put 8. And then I'm going to say divide by the 500. 500. Now, everybody's calculator is a little bit different. But it's 5 zeros, not 6. I think what you're doing is for that number at the top of the number, the big thing is times 10. Did you get it? It's like bouncing your checkbook. If it all agrees, then you're done. If it doesn't, you gotta go, well, what did I do wrong? I don't bounce my checkbook anymore. Oh my gosh. I used to. Very good. So how would we pack up 3 with 5 zeros? Oh, sorry, what would the units be? I'm not gonna rewrite this because I don't have the patience for it. But we came up with 3 with 5 zeros. Yeah, km per s. Perfect. Kilometers per second. And if I was going to pack that up into scientific notation, what would that look like? 3 times 10 to the 5th. Yep. km per second. Perfect. Now, I can't remember in this class if I talk about rounding or not. I don't hold you guys much accountable, but just round to what you think seems right. For instance, if this was 3027651 or something like that, you wouldn't actually, the word is justified, you couldn't say that you can actually give all those digits. You basically round to the fewest digits as what you divided out in this case. So 1.50 times 10 to the third, actually this would give us 3 up here. This is about rounding. That gives us 3 digits. This down here only gave us 1 digit. So you're only kind of allowed 1 digit. Okay, the next one. That's not a question. They give us the distance from Earth to Mars. And then they ask, using this information up here, this 3 times 10 to the 5th kilometers per second, how long in seconds, then in minutes, will it take for light to go this distance? So just kind of like I did over there, to work this, honestly, what I probably would do is, I wouldn't worry about scientific notation just because I think it's easier sometimes. I would take this and kind of what I call unpack it. So I would say that 3,000, what is it, 30,000? That 30,000 kilometers per second means 300,000 km over or per 1 second. I would unpack that so that I'm ready to use it as it is or flip it. It's exactly what we were doing a minute ago. So then when I work the problem, what's my first number going to be? It's going to be this number. What is that? So 225,300,000. So I'm going to put that over 1. So I have 225, comma, 3, oh, goodness gracious, 300,000. And don't forget the units, that's kms, over 1. Goodness gracious. Sorry, that looks just so terrible. Really, what does that mean? That number, it looks like a foreign language. What is that number? Km over 1. So if my kilometers are here, what can I do with my speed to get seconds? Flip it. Yep. Flip it good. Do 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 do. Okay. So I put 1 second on the top and 300,000 kms on the bottom. My kms cancel. I have units of seconds. It's a lovely world. So let's divide her out, see what we got. I'm going to go back up to the original problem because I can't read that. Wow. I got 751. Is that what you guys got? Okay, cool. And what would the units be? I'm liking it. Now there was a follow-up, 751 seconds. There was a follow-up to this question, and it says, I want the time in seconds, and I also want the time in minutes. Now to do this second part, I'm going to go ahead and I'll put it in the margins up there. 1 minute is equal to how many seconds? Yep, 60 seconds, exactly. We can take any equals like that, any quantity that are just out and out equals, and we can kind of make, it's like kind of like a per statement out of it. So we could say, for instance, that there are 60 seconds per 1 minute. Does that seem right? Oops, sorry, go back. We could say that there are 60 seconds per 1 minute, or we could say there's 1 minute per 60 seconds. Now, hopefully you're seeing this and you're like, wow, I've got something that I can use down here to go from seconds to minutes. So let's work that second problem. And I'm going to go ahead and put a semicolon, and I'm going to put 751 S for seconds over 1. Now, which of these two up here, I'll call this one A, and I'll call this one, this flipped version, B. So which of these, A or B, can I go ahead and put here so that seconds cancel and I'm left with minutes? She says B. Do you guys agree? Ah. Okay, so if I put B, 1 minute over 60 seconds. All right, let's divide her out. Now, I should probably just give it, well, I'm gonna go ahead and give it 3 digits. Because actually this, as it turns out, is what we call exact. So I'm gonna go 3 digits. So I got 12.5. Is that what you guys got? And then what would those units be? Minutes, yep. Any questions about that? Okay. Yeah, I asked you about the velocity thing. This was speed. Talk about velocity now. Or you know what I mean. Okay, so this is the second of 2. So go ahead and jot this down. This is also new. So just to recap, is drawing a picture when you work problems optional? Yes. Is doodling optional? Yes. Is using units optional? No. No. Thank you. Is showing all your work optional? Sometimes every once in a while students will be like, they think showing all your work means to like if you take 12 times 5, you actually show me a long multiplication. You don't have to show me that much work, but just how you set it up. Okay, that's all I have for today. Went fast. Me anyway. Be safe out there. And let me know if you need a copy of the book, but it seems like I'm just got one student I'm trying to cover with that.